So we are going to discuss shared virtual discovery environments, discovery shared tool shares as well. So case studies from Italy, concept-based searches, and as well as the Yono discovery tool. For the same, we have three stellar speakers who are joining us for this session. So I'll begin with introducing all of them. So I'll begin with Michele Castellini, who is the Managing Director of Castellini Library in Italy. Following studies in modern languages and literature and working with a publishing company, he's specialized in IT and management. He's been an active member in the standardization processes, such as the definition of EDIFACT for the book sector and the translation of IDA into Italian. Amongst his more recent interests are the digital transition and current situation of the HSS academic publishing. Our second speaker, Dr. Tiziana Posamato, who is a director at CULT and also chief information officer at Castellini Library. She holds a degree in philosophy and diplomas in archival science and library sciences, and also a master's degree in archival, librarianship and codicology. She is currently a doctoral researcher in library sciences at the University of Florence, with a project entitled Another Brick in the Wall, Building Bridges of Knowledge in the Digital Age. Our third speaker, Carola Blackwood, is the Customer Account Manager of Education at Yono INC Italy. With over 20 years in the publishing industry, ma'am has worked with academic institutions all over the world. Her areas of expertise include account management, training and customer onboarding, as well as marketing and technical support. So we have a diverse set of panelists with different interests, but also a common agenda of enhancing library technologies for the betterment of the world. So with this, I'm going to stop sharing my screen and I'm going to hand it over to Michele to begin the session. I urge all the participants to keep posting your questions on chat. Alternately, you can also ask it verbally after the session is over. With that, over to you, Michele. You can start sharing your screen.
But before Madam Michele starts, I would like to formally express our vote of thanks because it's not easy. So I want to say welcome, hearty welcome to Michele Castellini, Dr. Michele, Dr. Tiziana, and Dr. Carola. So thank you so much for accepting our invitation and addressing our participants. It's a great opportunity for all of us to hear the wonderful activities and services that you have been able to accomplish at with Share-VDE and Discovery too. Thank you so much.
Thank you. Thank you very much, Dr. Srikumar, and thank you all organizer of the Geo Institute workshop. It's a pleasure to participate to this international workshop devoted on designing digitally robust research libraries. The title of this Geo Institute workshop embeds perfectly the three key elements crucial from our point of view for the new generation of library professionals. International, that means opening up to new form of cooperation where the library domain can be central for bridging out in the archival, in the museum domain and beyond. Digitally, inevitable to avoid access barriers for authors on one side and for readers, this means students and scholars on the other side. And robust research that needs now more than in the past new tools that bring into practice what standard theoretical data models and technology today make possible, serving the need of efficient discovery capabilities among the huge and increasingly growing amount of information. I'm here with my colleague Tiziana Posemato, and we will talk about an interoperable model to build and maintain collaborative research catalogs. Next, please. The evolution of the internet with the semantic web and the need to use standards and languages interoperable with web technologies imposes a change in library practices. This means in the way libraries manage their data internally and share their catalog records with external systems. Just a few references before we start and dive in. Catalina Libri has a long tradition in supplying libraries with publications and bibliographical services with its role of International Bibliographic Agency, and acts with its sister company and technological arm at CALT. You have certainly, you certainly know about the MARC standards, and especially the MARC 21. And this morning you already, semantic web and the ingredients that built the semantic web environment. So the RDF syntax, the ontologies, and so were already mentioned in earlier today's sessions. Next, please. Also, also Tim Berners-Lee was already referred to today. And his quote, "The semantic web isn't just about putting data on the web. It is about making links so that a person or machine can explore the web of data. With linked data, then you have some of it. You can find other and relate data." This is, let's say, a manifest that is, quoted often when introducing linked data. Next, please. These are the main points of what we can call the linked data paradigm that summarize why linked data is so popular across the wide web community that spans over many different domains, and why it has enormous potentials for libraries. The data, of course, have information in it. Linked data builds the connections, and connections that can be enriched, and that altogether builds and enhance the knowledge. This is an, next please. This is an example of what happens when different data sources are connected through linked data. A book found in a library catalog redirects to a painting in an art gallery, to a statue in a museum, etc. It's not just simple an HTML link. It's about a way information is structured behind the scene on the web itself. Next, please. So with a mission in mind to bring all this into practice and building a linked data management system together with an entity-based discovery interface, and Tiziana will tell us in a moment what we mean with entity-based here. And building such a system, especially API-based, so that it can be replicated, it can be applied for a single institution, for a union catalog, for a consortia of library. So with this mission in mind, in 2016, the initiative called Share Virtual Discovery Initiative started with an initial research and development work, and that moved then on to a pilot project phase, and now to a permanent initiative. And next, please. The main contribution to the project has been given by the participant universities and national libraries, and was and is continuously endorsed by the vision of the Linked Data for Production initiative, and by the support of Stanford University. Next, please. There are now over 20 institutions in different continents that participate in this initiative. There are national libraries as the British Library, the National Library of Norway, the National Library of Finland, the Library of Congress, and several university libraries. And you see here a picture, and the full list can be found on the wiki of the project. There are also in the Share family group of initiative specific projects. One, for example, that is called Cubicat, devoted to the art sector, where we cooperate with the Max Planck Institute in Germany. After this very brief introduction to tell you a little bit what you will listen from now on, I turn to Tiziana that will dive you in more precisely into all these topics.
Thank you, Michele. So I will try to represent the evolution of the project over time. And we started with the of linked data workflow in production with different phases, different tasks, from the conversion from MARC to BIB frame, the creation of an authoritative cluster knowledge base, the entity cluster knowledge base, the enrichment of MARC, original MARC with the URI coming from the different sources, and in addition, the RDF dataset enriched with URI from different sources. All these data are stored and are made available in different technological environments. So in Postgres, in a triple store with the Sparkle query and the point, and in Solr inverted index to simplify and to optimize the searching by user. In addition, the data are published in a union catalog that is, as Michele mentioned before, an entity discovery platform, because the idea is to move from the record, traditional record, to an entity management, meaning for entity a real world object, which the standard of linked open data named real world object. And we are realized an APIs layer for CRUD operations and to make available all data to other communities for other projects. And so an interoperability layer with external systems such as LD4P. So as a next step and advanced services, a new authority control, so a rich workflow to manage this new generation authority control that work with entities and not as in the traditional with record. The shared entity editing tool for update and manage of linked data entities named JCricket. And generally speaking, we are trying to apply shared principles to other domains, for example, archives, museum, and music. So how the project gives us the occasion to meet other worldwide community. Share-VDE members put together universities and the national libraries in the US, currently in the US, Canada, and Europe. And here you can find a link to have all institutions. But Share-VDE is also a community that is connected with other library communities. For example, with the Library of Congress, BibFrame adopters, IFLA, LD4P, OCLC, Folio community. And in addition, Share-VDE evolved over time from an individual project to broader initiative comprising multiple branches, creating what we name the Share family. And finally, the Share family connection means connection with the wider web communities, so means Wikidata, schema.org, IIIF, GeoNames, and so on. The creation of more tenants, more branches in the Share family stems from the need to gather institutions with the similar scope or from the same domain in consistent groups, sharing the same areas of focus and far as the type of bibliographic information conveyed in their library catalog. This means, for example, that libraries specialized in the cataloging of visual material, so in paintings, artworks, photos, can be grouped in the shared art tenant and so on. From the management perspective, this allows more efficient data management and technological and economic sustainability. That is a topic, a very central topic. From the service perspective, this means that dedicated applications that are out of scope for certain branches can be developed for other groups of institutions. And finally, from the user perspective, this enables a richer and specialized set of resources to be consulted. This approach is reflected in the shared software architecture that is based on tenants' infrastructure and in the management of library data that are treated according to similar requirements and characteristics. The aim of this high-level schema is to reflect on the tenant architecture of the shared family with the purpose of achieving long-term sustainability and in the same time keeping autonomy of the various projects connected in the shared family. But a collaborative community can produce a sort of gravitational wave of energy that expands and meets other communities with other energy to share. This is the added value that we are experimenting: experience, knowledge, and tool sharing, where each bit attracts more experiences, knowledge, and the tools that enrich each other and exchange mutual energy. So community engagement, what is the Share-VDE working group? This is the group, the Share-VDE core group. And in this slide, it represents some of the institutions that contribute to disseminate the initiative. One of the most interesting results of Share-VDE is the ability of creating a wider community where we collaborate with external partners that apply linked data to the library domain. The collaboration with external parties in the linked data community allows us to interact with different domains of the LAM and the cultural heritage fields, librarians, art historians, and so on, and get more input to enhance the shared family and connect many different data sources. This means that different characteristics of each field are a useful asset that can be used to the advantage not only of the shared family as a whole, but for each single context. This is the scope and the idea of Share-VDE sister projects. While extending the circle of linked data experiences, different initiatives in the web can offer tools and expertise to the wider community, not necessarily specialized. Data and services are interconnected with each other. For example, we are integrating shared entity data with Wikidata and vice versa. So the scope is to have a circular economy of data exchange among different players. And so I can just show you some real example of this cooperation. So what viewpoint, this cooperation in a wider community can have as a final result. This is an example of a result achieved by the dedicated Share-VDE working group named CEI, the ability to handle different ontologies and vocabularies, combining the BibFrame-oriented approach with the IFLA LRM-oriented approach. This has been done in order to foster interoperability among the community of Share-VDE libraries that comprises different entity model in practice, and between other projects that apply pure BibFrame model. This represents just an attempt to harmonize different bibliographic traditions. And the final Share-VDE data model becomes a bridge between different worlds, and it represents the main trait of Share-VDE to be compliant with different visions. This is how we are achieving interoperability between models, particularly as there has been much lively debate on this recently. Another example of cooperation between working groups and the community is the design and the development of new authority service generation. While the concept of authority services has been related so far with the quality of bibliographic data within the library catalog, it is now opening to a broader dimension. The authority control can be considered as a tool to manage bibliographic entities, both for MARC-based workflows, as well as for the connection with external sources such as Wikidata, which mainly serves end users. The usability of bibliographic data is now wider than the local library system and goes in the direction of creating new relationships among the data. And these are two examples of how cooperation does not prevent the autonomous management of local library data. Autonomy means that it's possible for shared libraries data to live together on a shared platform and have at the same time an autonomous localization. These are some examples of this localization realized using the skin, and an example of a completely different tenant, so the Kubicat load. And again, speaking about integration with other projects, is important to mention the API's contribution. API's architecture simplifies interconnection and reusability, sustainability, and scalability. So in a word, in a phrase, API means an open windows to an open world. And so the API layer facilitates the interconnection with external load projects such as Folio, PCC, LD4P, and other projects. Result of cooperation with web technologies. This is another example. This is an example of how web technologies such as schema.org, not specific to the library domain, can now be applied to library data and enhance their discoverability and consumption. And the interaction with the Wikidata would allow searching the source and enriching the Share-VDE data with Wikidata entities information and vice versa, as I mentioned before. The editing tool under development named JCricket, designed by the Share-VDE working groups, will allow for editing the entity cluster knowledge base and to expand authority capabilities through the integration with external data sources such as Wikidata, ISNI, and others, with the ability to mutually enrich both Share-VDE data and Wikidata and ISNI platform. These are some examples of the Share-VDE 2.0 portal that that is a real entity discovery system where the entity that is a real world object is presented. It's an entity discovery system more and more oriented to the publication of entities and their respective relationship. And the portal is going through a full revision of the technological architecture with the addition of many functions, most of all for the end user. For example, the ability to view the same entity in different languages or alphabets, as in the example of who, she. And this is just an example. To finish, joining the Share family. In this complex transition period where the new linked data paradigm is changing not only data format, but also the services around the data and the community's mindset, no one can face on their own the challenges of this global revolution. We would like to leave you with the message that the Share family is an opportunity for all libraries to achieve synergies. Thank you.
Carola, ma'am, would you want to share your screen?
No, and before we go on to the next speaker, maybe we should just check if anybody has any questions at this point. And I do have to say, Dr. Pasamato and Mr. Castellini, that I am a technologist with some experience in libraries, and I do understand semantic web, the BibFrame model, RDF to some extent, but I have not understood, the Share-VDE benefits very well, to be very honest with you. And I was just wondering if you can give a very simple example, perhaps for me, and I'm sure for the other participants also, of why this platform and how this platform can help libraries and the libraries members.
I don't know, Michele, do you want to say something? Otherwise, I can try to answer.
Now, first of all, it's a way where libraries can enrich data on a common infrastructure, and this is very important, especially for those libraries that have in their priority also the maintenance of authority files. And so this cooperative way to validate data is one of the key elements of this new form of cooperation. The other one is the discovery. But Tiziana, I leave it to you because what the entity-based approach means you can explain it much better than I do.
Yes, I try to explain briefly. I start from the linked open data value. Because as you know, first of all, linked open data use a common language. So the RDF model. This means that it's not important if you apply BibFrame, LRM, or other ontologies to manage your data. This means that your data become understandable, not only by users, but by machines. This is the first added value. So what does it mean that a data can be easily understood by machine? That you can enrich your information. You can start from a flat information, a simple information, and with some different mechanism that the linked open data technology make available, for example, the interlinking with other sources, you can automatically enrich your data. We have this some example. This is an information. This who she entity description is not completely managed within the library. It's managed using data that comes from different sources. For example, the text that explain who is who she comes from Wikidata or Wikipedia, and other relationship comes for example from other sources that are specialized in these topics. So you can have your original data and you can enrich your data and use in the meantime information that comes from other sources. We have an example. For example, for GeoNames. GeoNames is a data set that manage a localization of places. So you are not obliged to define precisely your original data, where is Rome, for example, or some characteristic of a city that you want to express in your OPAC, in your discovery tool. You can use the information coming from another sources to enrich your information so that the user can navigate in this. And in the meantime, linked open data means the ability to share your data, because you use an open language that is understandable by all institutions that introduce linked open data. So you don't need some additional work to understand, for example, the data coming from VIAF, or the data coming from ISNI, or the data coming from JNAME or Wikipedia. You can use, and other communities can use your own data. So the characteristic is that data are defined in the same, in a format that is understandable by a machine, that is understandable for all institutions, and that can be enriched. You can build some different services starting from this principle. And for example, for Share-VDE, this means the ability to create a union virtual catalog with the data that start in many different formats, for example, in Unimark and Mark 21 and other formats, and put together in one union catalog that is in the same languages and that can be used by the world, by the whole world. So just to give you an idea, why Share-VDE? You have many different projects, and you have your own ability to realize a linked open data project, to share your data, to enrich your data, to enrich the performance in searching your data. Share-VDE is just an occasion, is a sort of platform with many actors that can contribute all together in defining and in solve this transition period.
Okay, so thank you for the explanation, for the detail that you went into. So am I right in understanding that Share-VDE is like a cooperative effort to build bibliographic and authority data, but using the RDF linked data format? Is that broadly correct?
Exactly,
Yes.
exactly.
Yes, exactly.
Share-VDE don't pretend to replace the local operational systems. So Share-VDE is exactly what you said, a system to maintain cooperatively authoritative sources and to build union catalogs that can be for a large group of catalogs. For example, Share-VDE more than 100 million of bibliographical records and more than 30 million of authority records, or it can be applied on a more, disciplinary level. Also with a totally open approach where the data can be reused for any other project that the library or the institution wants to start, but having this added value of a central cluster knowledge base and tool where the data can be validated and enriched by the wider community.
Okay, thank you. And so then the question then becomes, say, we at Geo Institute, if we want to be part of this collaboration, do we become a member? Is there a process? What are the governance aspects of this project?
Yeah, there is a membership model. The government is done through an advisory council where the participant institutions have a chair, and then there are specific working groups that contribute to to developing solution. For example, last year it was a very important year where certain aspects from the data model were enhanced, and there was liaison with the Library of Congress on one side, and with other institutions that maintain standards in the library domain, and the advisory council then made the final decision. So from this point of view, it's a very, let's say, democratic governance, because what we do is not coming from our heads. I mean, it's really coming from the librarians and from their vision.
Sure.
Yes. This is important to underline. The project, we are a sort of technological support of the initiative, but the initiative is completely oriented by libraries, and each library has a role within the Share-VDE group, has a role to share ideas, to share competence and knowledge, and also to choose which kind of services is useful for each own library, because not all libraries have the same exigencies. So to define, okay, which kind of project I have in mind for my library to join this new era of technologies for libraries and for all institutions.
Sure. Okay. Thank you. And just, one final question. I'm sure others want to chime in also. So if we are participating in this cooperative, we have access to data, and now we need the tools to use the data, right? So maybe the data has to be used in some kind of discovery interface. What about that part? I'm guessing the tools have to be compliant with standards such as RDF or BibFrame to be able to use this data fruitfully.
Michele. Mute. Michele, you are mute.
I'm sorry. So the tools are, on one side, the discovery tool is provided by Share-VDE, and Share-VDE will provide also the tool to manage manually the cluster knowledge base. At the same time, in parallel, there are a number of procedures that work in an automatic way to validate and to correct or to enrich the authority data in order to feed the cluster knowledge base. And all this data is given back also to the library, so that the library can reuse this enhanced data also for other purposes. So there is this mix of, let's say, threefold. There is the discovery for the general public. There is the cluster knowledge base editor. Tiziana mentioned it. It's called Jeremy Cricket, that enables library professionals to make to put their hands on the relationships of the data. I mean, if a cluster needs to be split, to merge, and so. And this has an important impact then on the quality of data that the end user sees. But as the data is huge, we must rely very much on automatic procedures, because, I mean, we are talking about, I mean, billions of triples, I mean. And so, I mean, most of the work is done through automatic procedures that, I mean, do a variety of activities. I mean, they identify the entities, they make the connections, they enrich the data, and they build all these bridges with external sources.
And they convert using the ontology that mainly BibFrame, but other ontology. So you need, imagine something like a pipeline where you start with your original data that for the first time is mapped so that they can be managed. And starting from this point, all happen automatically. So your data are analyzed, are enriched, are converted, are made available to the library, and are used to be indexed in the platform so that you can search. And in addition to this more traditional in a certain way workflow, you can also add some kind of services, for example, the quality of data, so that you can have have again your original data, but in a high quality, and you can reuse in your ILS. For example, if you are using an ILS that manage data in Mark 21, you can receive again Mark 21 enriched with the URI or corrected with the authority services, so that you can include and load again your system. So a large range of different services.
Okay. Thank you so much to both of you. Dr. Srikumar?
I wish to thank both the speakers, Dr. Mikhail and Dr. Tiziana, for bringing this very important concept. And we will definitely go through your presentation once again. We will visit those sites also, and then we'll try to include in our system. Of course, Avtraji was mentioning that we are interested in joining Share-VDE as a member. Let us see. Thank you so much. Thank you so much. In fact, we should pay special thanks to Dr. Mikhail, because he was saying that he doesn't want to because the time is short. But we have enough time. Don't worry. We have enough time. So thank you so much for this elaborate presentation.
Thank you all.
Thank you. I hope Dr. Carola, for patiently waiting. Thank you so much, Dr. Carola. Sanjayanji.
Yeah, Carola ma'am, I think you can share your screen now.
Okay.
And you can start your presentation.
I will. And moment, slideshow. Okay, do you see just my slide?
Yes.
Yep.
Okay, beautiful. Okay, well, thank you for having me, and thank you for allowing me to follow such an interesting presentation. I'm glad the question was asked, exactly the applicability, because I got lost in the technology, which was more complicated that I'm familiar with. So now I understand much more how it works, and it's actually kind of an interesting lead-in to what I'm going to talk about, which is sort of the artificial intelligence way of that we enrich records. One of the sides of what we do is we have a discovery search engine that displays results of ingested data, but we also have a lot of clients that give us their data, their repositories, and we return with them enriched records that we've pulled out of their data through artificial intelligence. So it's quite interesting how those two play along. So I'm Carola Blackwood. I'm located in Florida in the United States, and I work with all our customers around the world and helping them get set up. And I work with our engineering team, as well as I do all the training for our customers. I make all our videos and things along those lines. My colleague Manisha Bolina has done this presentation in the past, but Manisha has left us recently for an exciting position at digital science, and she sends her very best to all of you that she worked with in the past. So let me give you a little background about UNO. It's always good to start with that. So the roots of this technology go back to our founder, Ruggero Grammatica, who is from Italy, and he created this artificial intelligence algorithm for his PhD at King's College, and that PhD was in the area of econophysics. And it involved reading large amounts of structured and unstructured data for financial cycles. And then the next step was in 2010, the algorithm was used in a biotech company in Switzerland where it mapped specialized scientific publications in the area of drug repurposing. And that's when an introduction was made to Stanford University and Dr. Michael Keller. And Dr. Mike saw the potential for the technology and supported its development as he realized that this algorithm could be used with the whole spectrum of academia to de-silo content. And the technology was incubated at Stanford, and in 2015, UNO was born. And that brings us to current day, where we have various products and a lot of different clients in various verticals, from financial to corporate to education, from Australia to Singapore to Italy, the United States, Canada, US, and all sorts of wonderful places in between. So what exactly are we doing with this AI technology? So UNO uses knowledge graph technology, and we can liken the knowledge graph to the human brain. And that's the best way that I can think of how this AI works. So in this brain or knowledge graph, we're feeding it with lots of data. In our knowledge graph, we're feeding it with academic content. The knowledge graph is reading the full text of an article or an abstract or a full ebook, variety of dissertations, reports, news items, all sorts of content. About 500 million documents and more and more and more every day. And then it reads them, it understands them, and then it extracts meaning in the form of a concept. And this is the neural network modeling. It's making connections with other concepts in the knowledge graph, just like the human brain does. And within these 500 million documents, an inferential chain of connections is made, turning that information into knowledge. And let's dig a little deeper with the next slides into that. So UNO has created an inference engine, which gets smarter the more content it ingests. And that is the nature of machine learning and training. So for example, if you are just searching on the web and they're asking you to identify where do you see, click on all, like a CAPTCHA, it's called, and where do you see a traffic light? Click on all the squares where you see a traffic light, for example. That's all part of the machine learning for whoever is supporting that engine, so that they can identify they're capturing AI in that activity. So that's and the more that is done, the smarter the engine gets. So it's practice, practice, practice. But our goal here is not so much to ingest as much data or information as possible. Our goal is to extract knowledge from that information. And we've entered the knowledge economy, and that's built on the success of the last 50 years of the information economy. And so our goal is to understand context and meaning of this information by ingesting content from a multitude of cross-disciplinary sources. And then we extract meaning by correlating these concepts. These are some good examples here with Brexit and Nurofen or ibuprofen. So in UNO's artificial intelligence knowledge graph technology, we can identify concepts or keywords without being fed a specific list of terms. So there's not a particular ontology that needs to be fed. And this is critical for any platform to be up to date with all the new content being produced and language as it evolves, because no one person can keep on top of that and constantly update it. And it's able to do this because it can understand context and meaning, and concepts form these atomic units of information, and they are characterized by their description and their significance. So a concept is not identified only by its label, which is the word or the group of words used to describe it. It is semantically characterized via its definition and the set of topics or categories that it belongs to. So United Kingdom withdrawal from the European Union is political science, democracy, and then we have a definition for it. But there's a whole lot more to it because terms change over time. So the benefit of this type of ingestion versus traditional natural language processing, NLP, or keyword searching is that as language evolves over time, you don't have to worry about remembering a previous name. And the concept, because it's not identifying simply the word, but because the term itself carries a definition, it can ensure comprehensive results. And it doesn't matter if the word changes over time. The relevant content will always be surfaced without having to update old semantic metadata. So again, going back to Brexit, the UK withdrawal from the EU was first discussed in the 70s. Shortly after joining the EC, they actually wanted to discuss exiting. But the term Brexit was not coined until 2012. And artificial intelligence, our engine learned that and knows that these concepts are the same. So you don't have to do separate searches for both because it can infer that concept from the text. Also, if there are different names for the same thing, in some countries, this particular medication, this analgesic, is called ibuprofen. In other countries, it's called Nurofen, and there'll be other names perhaps in others, and then we will recognize that as well because of its definition. Another good example of this, of understanding context and meaning, is 3D printing. So 3D printing as a term was not coined in 1995 when the one article appeared, or in 2004, because the knowledge graph is reading text from the past and the present. It can read a back file and pick up concepts that the author or publisher at that time did not tag as 3D printing. So the metadata did not contain the term 3D printing, nor did the abstracts, but because we're using AI and we're using understanding context and meaning, the system can still find these documents when searching for content relating to 3D printing. So one of the things that's really interesting is disambiguation. So you have a term, for example, like depression, and you enter that into the search box of your library catalog or your discovery system, and then you need to start disambiguating. And you're talking depression. Are you talking about geology? Are you talking about meteorology? Are you talking about economy? Are you talking about psychopathology? Are you talking about clinical medicine? Are you talking about psychopathology and psychology? So there's all sorts of different ways that where depression can come fit in. So you really want to disambiguate very early in your search so that all the things that follow up will be correct. And UNO's technology will always ask you to disambiguate a term when you begin searching so that you can find what you need rather quickly and build a knowledge graph based on the correct result right from the very start. So that is the background on our software. So now I'm going to show you what it looks like. And I was going to do live, and then I thought I better not. I'm going to do a series of screenshots and also have some descriptions that you'll be able to see later, and just in case of internet connectivity, which of course is wonderful right now, but you never know. So this is the basic look and feel of our our canvas. And so we have our search box right here in the very top left, and you enter your search term. In this particular case, we'd entered artificial intelligence, and then right away you are asked to disambiguate. So you can focus on the exact term that you want to choose. And in this particular case, we wanted to look at the very first one, but you could have selected any of the others. And once you do that, you get a variety of definitions. And you can see that we have something from Britannica Academic. There's a definition from the medical subject headings for MESH, and there's also source, and source is usually Wikipedia. And most of our customers for Discover are academic libraries, and some will have a subscription to Britannica Academic, but not all. So we always have to have an openly available, a free encyclopedic definition for all our concepts. And that's why we use Wikipedia, and Wikipedia is updated so very quickly. And and if you look at Primo, if you look at Summon, if you look at so many of the discovery systems out there, when you search there, Wikipedia is generally the definition they give you for the very exact same reasons. It's because you don't have to have a subscription to the paid for model. So the first thing that you will see here then is a variety of definitions, and you can click through and see more information. But this definition then is what the concept searching will be based on. So it doesn't have to, you don't have to actually know the term. The system, the AI, will look for items that will fit in with that definition. And on the right-hand side is our knowledge graph. So when you indicated you want to see something on artificial intelligence, you now have looked over 500 million some odd items of documents that created this knowledge graph, and shows all sorts of concepts that are relevant to the search. And like before, like we have an artificial intelligence, every single one of these connections will come with a definition from a reference source. And then you can hover over any one of these and see how they are connected to one another. So we'd clicked on machine learning here, and if you notice on the left, we now have the definitions for machine learning. And then we see, okay, machine learning is also connected to physical symbol system, and it's also connected to natural computing, and it's also connected to pattern recognition, but it is not connected to artificial general intelligence. And we do have a way through our multi-select up here where we can infer a connection. I won't show that here, but so you can see, well, why aren't they connected? How would they be? What concepts are in the way? What would bring me from point A to point B? So we have a way that you can do a hypothesis that way. So going to the next step, when we selected artificial intelligence, now we redrew the knowledge map or our knowledge graph, and now we're seeing exactly how AI and machine learning are connected. And we can pursue any one of these nodes and see what more information that we can find. And we can also add another term. We can have up to 8 different concepts here in the knowledge graph, so we can keep expanding to include 8 different items. And we are asked to disambiguate again here on the left-hand side. And the knowledge graph will get drawn each time we add another term. And so I had added prosthesis and robotics. And now you're able to see how each of those are connected, and how prosthesis is connected to machine learning, is connected to robotics through the humanoid robot, how artificial intelligence is connected to prosthesis through robot. So you can make all these different connections. And then I had clicked on documents, sorry, I should have mentioned that. And now it reveals a list of documents for us. And we have a variety of ways of displaying them. We can either display the very most recent, or we can display them by relevance. So we have, this time, it defaults to by publication time, but you can certainly limit it to relevance instead. And then we have a variety of other filters here as well. We have a lot of our clients that ask us to ingest their electronic holdings, the items that they subscribe to electronically, specific databases they have, e-journal collections that they have, things they get from EBSCO, from ProQuest, whoever it might be, and they provide us with a KBART file. We upload that KBART file on a quarterly basis, and then those will be matched right here. And then you can select, I only want to look at things that are also available through the electronic holding, so that I can link to full text right away in my library. Similarly, we also have a limiter that is for free to read. So there's a lot of open access content available. There's a lot of free to read content that is from government sources such as the World Health Organization, the United Nations, and a lot of other organizations. We include all of that, and if you want to see that, you can click on free to read. So if you don't have, you don't upload your electronic holdings, you always have the free to read as well. And then if, in this particular case, if you, a specific collection that we can upload where you're publishing, your authors are publishing from your university, and you want to have a filter that shows us, I only want to see things that have been authored by someone from this institution, you can also limit it in that way. And then we have a lot of different document types. If you want to have only news sources, newspapers, these are for journal articles, different dissertations, book chapters, etc. And then you can limit by different topics that have been assigned. And then we can't see it right here down on the bottom, but you also have the ability to limit by time, by date range. So when we click on a strand between these two topics, what will happen is that we will actually get the results where we will see the documents that have both artificial intelligence as a key concept and robotics. So that's going to reduce the number of documents that we have. And then the result list will obviously be trimmed down and smaller. So looking at one of the results now, we have the title of a particular document. This is from the Royal Society. It gives us a link to the publication. You can use your link resolver and link to your library right here. And this information here, they're called snippets, and the snippet is not necessarily an abstract, it is a portion. If we only have the abstract of a document, it may be a portion of that abstract, but generally we have the full text, and it'll be a portion of the article or the book chapter that is most relevant to the concepts that we're looking for. So wherever artificial intelligence and robotics, where it is most relevant, those are the ones that are going to be displayed. And in this case, there's 4 of these sections, and you can just click on any one of these and to look at all of them if you like. And now you can see here that you can also limit your search by publication date. And then finally, we have a way to export our results. And we have this little snapshot feature that does a screen capture, which shows up in our journey. That's sort of our little save, where we save our different steps. And when you go to the journey, you can export your knowledge map, and you can export the different documents that you might have favored. You really can't save your searches per se, and with a link, because it is the product is updated constantly. So it's never going to take you back exactly where you were, but it does remind you of what steps had you taken, where had you gone. It tells us here that we had inspected prosthesis and robotics. We inspected artificial intelligence and robotics. So we'll remember that that's how we got to where we got. But it's not going to be a link where you can go back in there, because the content will be different each time. But you are able to export it, and you can then have the results go in the format of an RIS for a citation product, or in a CSV, and you'll always have the snippet in there as well. So that is valuable. It'll remind you what that particular document was about and why you exported it in the first place. And that concludes my presentation.